Okay guys, welcome to the fractional crystallization lab preview. Fractional crystallization sounds a lot like fractional distillation, but to distill means to purify by boiling. To crystallize means to purify by making a solute that is dissolved in a solvent fall out of solution as a precipitate. So what you'll see is like little crystals forming in your liquid and dropping to the bottom of your test tube. The idea behind fractional crystallization is that you're going to change the temperature of your solvent. So this is very similar to filtering, which we just did together in class on Thursday. You're going to be filtering two solids, and the two solids are sodium chloride and potassium nitrate. And if you look in your little brown book on page 99, or 98 I should say, there's actually a solubility curve for them. I'm going to show you that nice and big in a minute. And you're going to need that solubility curve because what you want to do is you want to figure out what temperature does your water need to be so that one of these two solids will dissolve mostly and the other one will mostly not dissolve. So let's look at that. If you look, here's the solubility curve for the two substances, and I just drew one as a blue line and one as a purple line. And you can see that the purple line is pretty much flat. As the temperature goes from 20 to 80 degrees, whatever that substance is, it's not dissolving much better as the temperature of the water gets hotter. On the other hand, whatever B is, the other substance, the blue one, as temperature gets hotter and hotter, it becomes way more soluble. So by the time we get to 80 degrees, look how far apart they are in solubility. We want to take advantage of that fact. This is similar to what we did with the sand and the salt. At room temperature, sand doesn't dissolve at all, but salt does. So at room temperature, which is 20 degrees, these two substances more or less both will dissolve about 10 grams in 100 milliliters of water. So that's not helpful. If we put 10 milliliters of water, then that would mean, by proportion, if 10 grams dissolves in 100, then 1 gram dissolves in 10 milliliters. So that's not going to be that helpful. We're going to get the same amount of each substance dissolving. So instead of doing this at normal temperature, we're going to heat our water up to 80 degrees. And then if we filter, this guy will dissolve a little bit, but this guy will totally dissolve. So when we filter, we'll get this in our filter paper and this in our water. So to do that, what we're going to do is figure out how much will dissolve of each of our solids in 10 milliliters of water. So you have to do that. So on your lab sheet that you've been given, you're going to use the chart on page 98 of your IPS book, this guy. Can we see that, Mr. N? You're going to use that chart to figure out if you had 10 milliliters of water, how much of these two substances will dissolve at 80 degrees or at 70 degrees. You can actually do, because it's on the chart, is 70 degrees. So figure out how much of each of them should dissolve. And I'm going to tell you how much of each of them you have in your container. But do that, and the person who's leading the lesson can pause this video so you can do that, and then you can start up again. Okay, so once you have that figured out, and we'll talk about that, if you don't have the right numbers, it's okay. I'll explain it to you on Monday. Once you do that, what we're going to do is just filtration, right? So what we're going to do is we're going to take, we're going to try not to knock everything over. We're going to take a funnel with filter paper. We're going to take a test tube. We're going to mix up our substance. Let me get this going here. Oh, my test tubes don't hold my funnel. How annoying. I'm going to mix up my substance. Hold on. Put the funnel over here. Put the funnel over here. See, this is why lab partners are fun. We're going to pour our substance through our funnel into our test tube. There it goes. And now what we want to do is we want to add solvent. We want to add water. But remember, we don't want to add 20 degree water. We want to add 80 degree water. We want it to be 70 degrees, but we're going to add 80 degrees so it has some room to cool off. So what you want to do is heat some water so that you get some nice hot water. And I got myself, looks like about 100 milliliters of water. That's way more than we're going to need. We're only going to do 10 milliliters of water. But you're going to need the extra water, and I'll tell you why. So for the sake of time, I'm not going to, wait for my water to get hot. But what you're going to have is a thermometer stuck to your pegboard with a clamp. And you'll see that I have pictures of this in the lab sheet, so you'll know exactly what I mean. There's a little stopper in the thermometer, and the clamp holds the stopper. And that way you can read the temperature of your water. So you'll know when it gets to 80 degrees. When it gets to 80 degrees, you're going to use this little pipette. And you're going to get yourself 10 milliliters. I had a graduate cylinder. Oh, there it is. Of your 80 degree water. And of course, I picked a 5 milliliter cylinder. But pretend this is a 10 milliliter cylinder. I apologize, everyone. This way you don't have to pour from the hot beaker, because it'll be hot-ish. So you'll pour your 80 degree water in, and then you'll grab a stopper. Oh, I had stoppers. Hold on, I'll grab a stopper. Hi, everyone. Unprepared teacher. Okay, here we go. And you're going to shake it up. Now, your water's at 80 degrees so that we want it to be at 70, right? So as we're doing all this, it's going to cool. So that's why I wanted to heat it to 80, so I have time for it to cool. We're going to leave the water heating here, because we're going to use that water in a sec. After we shake vigorously for about a minute, making sure all of the solid that dissolves better gets dissolved, then we're going to pour into our filter into another test tube. But, and this is really important, before we do this, before we filter this through into this test tube, now comes the time where we want to actually pour this semi-hot water through. And actually you want to do it, I have extra test tubes here so that we can just pour the water through. Now all I'm trying to do is heat the filter. That's all I'm trying to do. Because if I don't do that, then as soon as this mixture, this hot mixture hits that cold paper, it's going to drop the temperature suddenly. So what I want is for this filter paper to be warmed up to about 80 degrees. I get it that way by pouring that hot water through. As soon as I pour the hot water through, my filter paper has been pre-warmed. Now I can filter for real with my real substance. And I just pour it through. Get everything out. And in here should be the solid that dissolves better at high temperature. In the filter paper will be your solid that doesn't dissolve as well at high temperature. Now, the trick is, you want to have ice water. Put your test tube in the ice water and let it sit. As it cools off, the solid that dissolved better at high temperature will start to crystallize and form little snow and fall down to the bottom of your test tube. When this test tube gets down to 20 degrees, we can filter it again through a second funnel. So imagine this is a second funnel with filter paper. And I'm going to take my now 20 degree water, which will have lots of precipitate at the bottom because all that stuff that dissolved at 70 degrees is not dissolved anymore. And I'll pour it through. And what will happen is you'll have, again, more solid in here. And you'll have a little bit of stuff that's dissolved in here that you can actually evaporate the water away like we did with our salt and get it back. Now I know this is a pretty complicated procedure, which is why I gave you lab sheets to try and figure out as much of the process as you can. And then on Monday we'll go over that before we actually do the lab. So hopefully you get something out of it. Fill in those lab sheets. I do want to collect them on the lab sheets. I'm giving you procedures. So here's the procedure, here's the question you're going to answer. You've done this before. So there's 8 steps in the procedures, and it asks you for each step, why are you doing that? And then I gave you pictures that I drew, because I know some of you don't like to draw very much. So you can use these drawings to trace your own drawing of what the setup is and how to do this. So you can make yourself a step-by-step instruction sheet using pictures. And I will have instructions for you to do that as well. So hopefully you guys get a lot out of this. I'm expecting you to try as hard as you can so that when I come back on Monday, we can kind of just go over a few things and